Hello students. Next question. Identify the correct order of reactivity for the following pairs towards the respective mechanism. Now option A. The mechanism is SN2 mechanism and these are the two alkyl halides. Let this be alkyl halide 1 and this is alkyl halide 2. Now it is given that alkyl halide 1 is more reactive towards SN2 mechanism, or it undergoes nucleophilic substitution by SN2 mechanism more readily than the alkyl halide number 2. Now if we see this alkyl halide number 1, then the carbon which is bonded to the halogen atom, it is the primary carbon atom, and in alkyl halide 2 the carbon bonded to the halogen atom is tertiary carbon atom. Now, primary alkyl halide undergoes nucleophilic substitution by SN2 mechanism more readily than the tertiary. The reason being, in primary alkyl halide, the steric hindrance near the carbon atom, which undergoes the nucleophilic substitution, is less in comparison to the tertiary alkyl halide. Now, this carbon, in case of tertiary alkyl halide, the carbon which undergoes nucleophilic substitution, it is surrounded by 3 methyl groups. So, there is a lot of steric hindrance, because of which it does not undergo nucleophilic substitution by SN2 mechanism. So the order shown in option A is correct. Now in option B, again here it is about substitution nucleophilic unimolecular, means mechanism followed is SN1. So if this carbon bromine bond breaks, the carbocation which is formed here, the positive charge gets delocalized in the benzene ring. These pi electrons will come here and the positive charge will get delocalized on the benzene ring. But in this alkyl halide, if this carbon bromine bond breaks, the positive charge does not get delocalized on the benzene ring. The reason being, in case of alkyl halide number 1, the positively charged carbon atom is directly bonded to the benzene ring, so the positive charge gets delocalized in the benzene ring. But in case of alkyl halide 2, the positively charged carbon is not directly bonded to benzene ring, so no delocalization of positive charge takes place. So the compound 1 undergoes nucleophilic substitution by SN1 mechanism more readily than the compound 2. The order of reactivity shown in option B is also correct. Now C. Chlorobenzene. In chlorobenzene, chlorine atom is bonded to the benzene ring and chlorine has lone pair of electrons. These lone pair of electrons get delocalized on the benzene ring, creating a negative charge density at ortho and para positions, because of which ortho and para positions become rich in electron and they easily undergo electrophilic substitution reaction. This chlorobenzene is reactive towards electrophilic substitution reaction, but if there is a nitro group present at the para position, now NO2 group being electron withdrawing group, reactivity of para nitrochlorobenzene towards electrophilic substitution decreases, because this NO2 group attracts the electron towards itself, because of which the electron density in the benzene ring decreases. So the order of reactivity shown in option C is also correct. Now option D. In option D, this is bromobenzene and here there is a NO2 group present at the para position. Again, this bromobenzene is less reactive towards nucleophilic substitution reaction in comparison to the one containing NO2 at the para position, because nucleophilic substitution means nucleus seeking group. A group which is rich in electron will attack the benzene ring where the electron density is low. Now since NO2 group is electron withdrawing group, it decreases the electron density in the benzene ring and makes it more reactive towards nucleophilic substitution. So the order of reactivity shown in option D is also correct. Now for SN1 and SN2 we can also write, for SN2 reaction the reactivity is inversely proportional to steric hindrance, and for SN1 reaction the reactivity is directly proportional to the stability of the carbocation. Now since the order of reactivity shown in all the options A, B, C and D are correct, so here the correct option is option 4.